Hey guys, it's me, Mr. Miller. We're going to talk about states of matter and changes of state, which should be reviewed from elementary school. So here we go. Let's see. We're focused on what are the three states of matter, but first of all, what is matter? Well, we've already learned that matter is defined as anything that has mass and takes up space. Atoms are in constant motion, and we're going to talk about the motion of those atoms when we talk about solids, liquids, and gases, the three main states that we're going to review. Let's focus on solids right now. Solids, in terms of their shape, they have a definite shape. They have a definite volume. The atoms are packed close together and they vibrate in place. As we said, they're always in motion. Even though they're packed together, they're vibrating in place. Liquids. Liquids have no definite shape. Why? Because they always take the shape of the container you pour them into. Their volume, though, is definite. No matter what, the volume stays the same, no matter what the shape of the container is that you pour that liquid into. The atoms, though, are spread out just a little bit. You can see in the picture here that the atoms are spread out a little further. They can move around each other, which allows them to flow and be poured. Now, as they move, they obviously have more kinetic energy. Kinetic energy is energy of motion. Our third state of matter we're reviewing is gases. Gases have no definite shape, no definite volume. Why? Because gases will take the shape of whatever container you put them in. Put them in a balloon, they take the shape of the balloon. Put them in our classroom, they take the shape of the classroom. Same with volume. No definite volume because they take up the space that they're put into. So they have no definite shape, no definite volume. The atoms, though, are moving very fast, super fast. They're bouncing off each other. They're just going crazy. They have the most kinetic energy. The more heat we apply to it, the faster they're going to move. So that's why when you take a balloon and you put it in a hot car, it will expand. Those molecules, those atoms are moving faster, so they're going to expand and push out. They move slower when heat is taken away. So you take your soccer ball, put it outside in the garage or the shed, and it's cold out, and you come back to it a week later, you notice the ball's a little bit flat. That's because the particles of gas are slowing down and they don't have as much energy. Now let's review our changes of state. We've already talked about this in elementary, but we're going to add two new ones to this. A change of state is a change of substance from one physical state to another. So examples would be from a gas to a liquid or a liquid to a solid. During a change of state, energy is either gained or lost. To change a state, we either have to add the energy to it or we take energy away. And if you look down here, as we add energy, those particles move faster and they break apart and form liquids. As we add more heat energy to them, they break apart and they now start flying around. They now change to a gas, and you add the most amount of energy we can to it. Now we've reached the plasma state. Now, when we talk about matter or changes of state, we said energy is increasing or decreasing, and the speed and the distance between those particles also increases or decreases. Let's take a quick look at this video, which will show what I'm talking about. Alright, so when we look at solids, we notice the temperature is very low, particles are vibrating in place, they have a definite shape, definite volume. Now, as I raise the temperature up, that solid begins to melt, the particles break apart from each other, now they're starting to slowly flow around each other. They definitely are moving there. Now we take a look at the gas, increase the temperature more, such as boiling. You can see the molecules of that gas that are escaping are now flying around as they go from a liquid to a gas. As we go backwards, we start to cool it back down again, it condenses. The particles go back to a liquid, they're closer together, and then we go back to a solid and we freeze it. You can see the particles now slow down a lot, quite a bit there, and now they're just vibrating in place. Okay, so now we go back to our screen. Let's talk about each of those changes of state. Let's talk first about melting. Melting is going from a solid to a liquid. Energy is being added because we obviously are melting it. Particles speed up a little bit, temperature rises. This is known as a melting point. It's the temperature at which a substance changes from a liquid to a solid. Melting point is 0 degrees Celsius or 32 degrees Fahrenheit. Freezing. Freezing is the opposite, going from a liquid back to a solid. We have a loss of energy here. The particles now start to slow down as the temperature cools. This is our freezing point, which is the same as the melting point, 0 degrees Celsius or 32 degrees Fahrenheit. Evaporation is going from a liquid to a gas. To do that, we have to add heat energy. The atoms gain energy, they move faster. And evaporation only occurs at the surface. So think about a water puddle after it's rained. It goes away in an hour. That's because of evaporation. It's only occurring at the surface. Now you have vaporization. It's the same, it's just liquid to a gas, but it's occurring throughout the substance. Vaporization, think of as boiling. It's happening throughout the whole substance. Boiling point is 100 degrees Celsius or 212 degrees Fahrenheit. Condensation is going from a gas back to a liquid. So we're cooling the gas. Temperature is decreasing, particles lose energy. Think about the bathroom. You take a shower and all that hot air in there as it gets near your mirror in the bathroom. Notice all the condensation that's occurred on there. That's because as those fast particles are moving, those gases, near the cool mirror, they slow down enough that they go from a gas back to a liquid and they condense actually on the mirror. Sublimation is going from a solid to a gas. This is our new one. It completely skips the liquid phase. We had so much heat that the atoms gain so much energy they completely skip over the liquid phase and they escape as a gas in the air. One example is dry ice. Finally, deposition. Gas directly to a solid. The substance cools so quickly, the atoms lose so much energy so quickly that we skip the liquid phase and go right to the solid. Example would be like frost that you see. So that water vapor turns directly to ice crystals outside on the trees or on the mirror. Finally, what happens during that phase change? Temperature remains constant until the change is complete. So here you see some ice. As the ice continues, as our temperature goes up, notice here it's going up degrees Celsius. As soon as it hits degrees Celsius 0, that's when the ice starts melting. And as it starts to melt right here at 0 degrees, that ice will start to melt, turn into water. But during that whole phase change, it will stay the same temperature until that little bit of ice is completely gone. So that's that flat line. So as time is going on, the temperature remains constant at 0 degrees until every little piece of ice chunk is gone. As soon as that little ice chunk is gone, immediately the temperature continues to rise and will continue to go all the way up to reach the boiling point, and then you'll see another flat line and it'll stay at 212 degrees Fahrenheit or 100 degrees Celsius until all the water is gone. So that's how that works. Okay, that's the end of our notes.